Chapter 4.3. In this chapter, we'll cover congruent triangles. The definition of congruent polygons is that their corresponding parts have to be congruent. So their corresponding angles have to be congruent, and all the corresponding sides have to be congruent. When we have a congruent statement, how we order that congruent statement is very, very important. Here, this one tells us in the two triangles that angle A is congruent to angle H, which it is. Angle B is congruent to angle J, and angle C is congruent to angle K. It also tells us that segment AB, so segment AB, is congruent to segment HJ. So the ordering is extremely important when we write down a congruent statement. Looking at the first example, it asks us to show the polygons are congruent by identifying all the congruent corresponding parts and write a congruent statement. So in a problem that asks you to do this, you have to list all the angles that are congruent and then all the sides are congruent. If we're looking at this, it tells us that angle A is congruent to angle R, angle B is congruent to angle T, angle C is congruent to angle P, D is congruent to S, and E is congruent to Q. Once we have those congruencies, we have to go around the sides and make sure they also line up. So AB is congruent to RT, BC is congruent to TP, DC or CD is congruent to SP, and ED, we'll put a circle there, is congruent to QS. So to make the statement, we have to write in the right order. So I'm going to start with this angle and go around. So polygon ABCDE is congruent to polygon starting with the same angle, going in the same direction, RTPSQ. The support beams on the fence form congruent triangles. In the figure, triangle ABC is congruent to triangle DEF. So AB, this segment here, is congruent to DE, which is this segment here. Angle A is congruent to angle D. So which of the following congruent statements correctly identifies the corresponding angles or side? So here, angle ABC is congruent to angle EFD, so it's saying that angle B is congruent to angle F, and that's not true. In this statement here, it says that angle A is congruent to angle F. Again, it's not true because A is congruent to D, so that one's not true. BC, these last two letters here, is congruent to DE, which again is not true. Looking at the last one is saying that AC is congruent to DF, and those do line up in the correct order, so the answer is AC is congruent to DF. In the diagram, triangle ITP is congruent to triangle NGO, so IT is congruent to NG, TP is congruent to GO, and IP is congruent to NO. And we want to find the values of X and Y. So here, X and Y, NG, we know that NG has to be equal to IT. So X minus 2Y equals 7.5. We also know that this angle here, angle O, is congruent to angle P. So angle O is congruent to angle P. So 6y minus 14 equals 40. If I solve this second equation for y, I can plug the y back into the first equation. So 6y equals 54, and y equals 9. Plugging it back into our first equation here, we have x minus 2 times 9 equals 7.5. So x minus 18 equals 7.5. So x equals 25.5. And we solve for both of the variables. So they give us in this next problem that triangle FHJ is congruent to triangle HFG. And they want us to find the values of x and y. So I know that angle F, this angle here, is congruent to angle H in this second triangle. So I know that 6x plus 8 equals 35. Solving that for x, I have 6x equals 27. So x equals 4.5. I also know that FJ is congruent to HG. So 2y minus 3 equals 2.5. 2y equals 5.5. Y equals 2.75. So the correct answer is A. The third angle theorem tells us that if two angles of one triangle are congruent to two angles of another triangle, then the third angle has to be congruent. So in other words, with these two triangles, if C is congruent to K and B is congruent to J, then A and L also have to be congruent. So this drawing of a tower's roof is composed of congruent triangles, all converging at the top in a point. They're telling us that angle IJK, so IJK, this one right here, is congruent to IKJ. So since they're congruent going all the way around, we know all the angles are congruent. So if except for the top, all the bottom angles are congruent. So if IJK, this one here, is 72 degrees, find JIH, find the one here at the top. So we know all the angles of a triangle have to add up to be 180. So if I do 180 minus 2 times 72, because each of the bottom angles here are 72 degrees since they're congruent, and that's the same all the way around, I will come up with the missing angle that I want, and the answer would be 36 degrees. So this top angle all the way around is 36 degrees. A drawing of a tile contains a series of triangles, rectangles and squares, and a circle. If triangle KLM is congruent to triangle NJL, and angle KLM, so this angle right here, is congruent to angle KML, which is this angle here, and angle KML is 47.5. Find the measure of LNJ. So this one here at top. Well, we know that these angles right here are congruent all the way around. So again, I would do 180 minus 2 times 47.5, which will give me 85 degrees. So we want to write a two-column proof, and we want to prove that the two triangles are equal to each other. So triangle LMN is congruent to triangle PON. So our first step is to write the given. So we have angle L is congruent to angle P. So angle L is congruent to angle P. LM is congruent to PO. LN is congruent to PN. And MN is congruent to OP. So we have all the sides are congruent. And we want to prove that the other two angles, corresponding angles, are congruent. Well, I know that these two angles have to be congruent to each other because they're vertical angles. So angle LMN, LNM is congruent to angle PNO, and that's because vertical angles are congruent. So now I know that angle M is congruent to angle O by the third angle theorem. Since two of the angles are congruent, the third one has to be congruent. So now I have triangle LMN is congruent to triangle PON. Because all corresponding angles are congruent, all corresponding sides are congruent. So all corresponding parts congruent. So the first step in this proof was to list two of the given, that QN was congruent to OP, and that QP was congruent to ON. I can say that this side that they share is congruent to itself by reflexive property. I was given that angle Q is congruent to angle O, and that angle NPQ, this one right here, is congruent to PNO, this one right here. So I know that the third angle is congruent by the third angle theorem. And the two triangles are congruent. You can either write because all corresponding parts are congruent, or you can write the definition of congruent polygons. Either way. The last little bit of information in the presentation says the properties of triangle congruence, which means that all the properties we had before, reflexive, symmetric, and transitive, works for triangles also. The remaining problems are problems for you to practice. The solutions are online in the handout notes, so you can look at those solutions, but they are problems for you to practice for an upcoming quiz or upcoming test.